5.4, slope is a rate of change. Slope is a rate of change. Now, it's very important to note that slope can be defined by different words. Slope can be named slope, it can be named rate of change, and it can be named as a constant of variation. Today we're going to look at rate of change. Rate of change is basically a change in a quantity relative to the change in another quantity. So we've seen this in real life. A rate of change requires units, such as kilometers per hour, meters per second, dollars per pound, dollars per liter. We've seen that in gas, we've seen that in speed limits, we've seen it in science, and we've seen it even in the grocery store when we're buying fruit. Well, a rate of change always has some comparison with units. When a relation is graphed, the rate of change can be found by calculating the slope of the relation. Now, to find the slope of a line segment joining 2 points, you can use a formula. We use m, to represent slope or rate of change. The formula that we use for slope, which is rise, is you subtract the y values. Over the run, which is when we subtract the x values. Or another way to represent the formula is to write out y2 minus y1 over x2 minus x1. Now back here, notice again, the top is always subtracting the y values because that has to deal with the rise. How far does it go up or down? That's your rise. Subtract the x values is your run. That's the difference in the x values. Again, note here, x2 and y2 are together because they are 1 point, and x1 and y1 are another point. And what we have is a formula here that we can use to find the slope or rate of change between variables. Let's look at an example. Example 1. Determine the slope of the line segment with points at 2, 3, 5, 11, -9, -7, and 1, -2. What are we going to do? Well, when you have 2 sets of points as such, there's a neat little trick with the formula that you can use to be able to always get the slope answer. And that is, the slope is equal to, what you have to do is take the point that we have, 2, 3, and 5, 11, and use the formula. How are we going to do that? Well, x1, y1, x2, y2. Notice I have x2, y2 here. I write those points, that coordinate going upwards. That's right. We write 5, 11 going upwards. X on the bottom, y on top. And then what we do is we take the first point, x1, y1, and we put that going upwards. So one more time. We take one point, put it upwards. We take the other point, put it upwards. And the last thing we will do is draw 3 lines. One here, and finally one here. That's right. Let's try that again. We will draw 3 lines. One here, one at the top, one in the middle, and one at the bottom. What we've done here is created the rise over the run. 11 minus 3 is 8. 5 minus 2 is 3. So my slope, folks, is 8 over 3. Remember that the fraction must be reduced and in simplest terms. All right, let's try the next one. -9, -7, and 1, -2. y2 minus y1 over x2 minus x1. You have x1, y1, x2, y2. But folks, what we're going to do is do exactly what we did before. Take this coordinate and write it upwards. take the other coordinate and write that upwards. So that's all we're doing, is writing the coordinates upwards. The next step, draw 3 lines. 1, 2, and 3. And notice that this minus minus becomes plus, so we will have -2 plus 7, which will give us 5. And on the bottom, we will look at 1 minus minus 9, which will give us 10. Now 5 over 10 is not an acceptable final answer, folks. It's an answer, but it's not the final answer. The final answer will be 5 over 10 reduced, which is 1/2. Do not forget to reduce your answer. Okay, moving on. Example 2. Mark is on the soccer team and runs every morning before school. One day he ran 5 kilometers in 20 minutes. Calculate the rate of change of Mark's distance from his starting point. So, what we're going to do is determine his rate of change. How do we do that? Well, he runs for a certain amount of time in minutes and compare that to the distance that he's run in kilometers. So, Mark at 0 minutes has run 0 kilometers. Next one, we want to run 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, 5 kilometers. We know at 5 kilometers he's run for 20 minutes. What are all the values that go in between here? Well, they would be 4, 8, 12, and 16. Why is that? Because remember, what we do is we know it takes 20 minutes to run 5 kilometers. So we need to divide and figure out how much it is for 1 kilometer, for 2 kilometers, for 3 and 4. And we find out that when we take 20 divided by 5, it takes him 4 minutes for 1 kilometer. That means to double that, you double his time. To triple that, you triple his time, and so on to get to this level. But what we have here is we've determined his rate of change. What it is that, now, before we even do that, let's look at that. Let's look at these diagrams. What do these diagrams remind you of? Well, previously we learned that these have something to do with partial and direct variation. This one is a partial variation because the graph does not go through 0, 0. Direct variation goes directly through 0, 0. What does this table represent? A direct variation or a partial variation? Well, by looking at the coordinates of 0, 0 being in the table, because 0, 0 is in the table, we know for sure that this table represents a direct variation. Next, moving on. We need to look, so there's our direct variation because it's 0, 0. And then we need to calculate the rate of change. What is Mark's rate of change? Well, that is, Mark runs 5 kilometers in 20 minutes. So we need to know how many kilometers he runs per minute. So he runs 1 kilometer in 4 minutes. Or, better yet, understanding that it's how many kilometers per minute that he runs. And what he does is runs 0.25 kilometers per minute in order to run his 20 minutes for 5 kilometers. So again, we take kilometers per minute, and this is the rate of change that we're trying to calculate. And we find out that 5 kilometers in 20 minutes means that he will run 0.25 kilometers per minute. Okay, moving on. Example 3. The graph shows the volume of gasoline remaining in a car's tank. Calculate the slope of the line, and then express the slope as a rate of change. So here we go. We need to calculate the slope. To calculate the slope, we have 2 coordinates listed right here for us. So we need to find the slope of that line. Well, that is 0.65 Okay, so now don't forget, those are our two coordinates, 0, 65 and 505. And we're going to use our slope formula to find the value. So our slope formula is y2 minus y1 over x2 minus x1. So we write out the points going upwards. That's right. So 505 for the first one, going upwards. 0 and 65 for the second one, going upwards. And then what we're going to draw is, that's right, 3 lines. 1, 2, 3. And what we've done now is use the points to find our slope. What is our slope? Well, we're going to read 5 minus 65 in the numerator is going to be negative 60. In the bottom, we're going to have 500 minus 0, which is 500. Now this is not reduced. So we need to reduce this value, and we get negative 3 over 25. Now, normally you would leave slope like this. That's reduced. But remember that we need to express the slope as a rate of change. So in order to answer B, we need to go one step further and write the decimal. What that means is that the rate of change of this particular gas tank is negative 0.12. Negative 0.12 what? Well, the rate of change would be negative 0.12 liters. That's the y values over the x. So liters per kilometer. So that means, what does it mean? Well, that means that the car, why is it negative? Because it's losing or using 0.12 liters for every kilometer driven. That's what this rate of change is representing. So you not only have to be able to calculate the rate of change, but you also have to be able to understand why you have certain values, and sometimes those values are negative. All right, folks, well, that's the end of the lesson. Have a numerical day.